Okay, welcome back. This is the second video and the last video for the week of 427 for pre-calc. First video, we did half angle formula. We used sine and cosine. There's also a tangent for half angle. It's just I didn't use it in that video, so I didn't put the formula up. Again, you can find it online or on your cheat sheet. It's all readily available. And then we also did a throwback problem. This time we're going to be doing double angle on this video. I'm going to be doing one problem for double angle. It's going to be involving tangents. That's why I put the tangent up there. Again, there's double angle formula for sine and cosine as well. I'm not putting that up just because I have limited space. But again, that's available for you too. Okay. So first thing we're going to do is we're going to do double angle, and we're going to look at it like this. Find tan of 2 theta, so that's double the theta. Okay, that's why it's called double angle. Tan of 2 theta. But then I'm going to say if tan of theta, which I'm going to give you, is equal to 5 over 3. Okay. Don't try to go look into the unit circle to find out what angle that is. It's not. You're not going to get it. It's not going to be available in the unit circle. That's the whole point here. Okay. If it was, then that would just be take 2 seconds. So I'm telling you the tan of theta is 5 over 3. I want you to find out tan of double that. Well, okay, let's see what's going to happen. You don't just double that. It's not that simple. We have to double the theta. Well, we don't know what the theta is. And you're not using a calculator here to figure out, oh, let me do tan inverse. No, okay? Use the formula. So tan of 2 theta is equal to 2 times the tan of theta. Well, wait a minute. I don't need to write tan of theta. I know what the tan of theta is. The tan of theta is 5 over 3. All over 1 minus tan squared theta. But wait a minute. Again, I know what tan squared theta is. I just have to get tan of theta, which is 5 over 3. Square that. That's it. 5 over 3 and square. And now it's just straight up algebra. That's all we have to figure out. 2 times 5 is 10 over 3 all over 1 minus, let's do this out. Let's work this out. 5 over 3 times 5 over 3. It's going to give us 25 over 9. Okay, so we want to work that out some more. We need to subtract these. We need to get the same denominator. I'm just going to make 1. I'm going to make that a 9 over 9. Okay, so fast forwarding it. And then I'm going to do this. Equals, let's go, 10 over 3 over 9 over 9 minus 25 over 9 is going to get us negative 16 over 9. All right, well, we're almost done. We're almost done because now I'm going to rewrite this as 10 over 3 divided by negative 16 over 9. And remember, when we divide two fractions, keep, change, and flip. Okay, and now I'm just gonna multiply those out. But before multiplying those out, I'm gonna top and bottom. I can simplify. That's gonna divide by 3. That's gonna divide by 3. That's gonna divide by 2 to be 5. That's gonna divide by 2 to be an 8. Let's simplify that. And now I'm going to multiply. Don't forget there's a negative here. So it's negative 15 all over 8. And that's our final answer. We just used the formula, plugged it in, and then just did algebra. Okay, 2 more problems I want to show you guys, and it's not having to do with double angle. That's the one double angle problem I'm going to show you guys. I'm going to erase this. Okay, and they're all pretty much the same. That's how they're going to be. Just straight up algebra. Okay, next one I want to show you guys. A couple throwbacks is graphing with a square root, something like this. What did I put? Let's just go y equals square root of. Well, y equals square root of x. All right, let's think about this for a second. What you get on something like this is if I were to plug in a number, 0 for x, that would get 0. Great. If I put 1, well, the square root of 1 is 1. Now, you may also say, well, the square, you know what, I'm going to make this an f of x. Well, you may also say, well, the square root of 1 is actually also negative 1. I can graph that. So 1, 1. Now, if you say 1 and negative 1, what will happen is you'll have a thing here. You'll have a point there. And you cannot have this whole sideways parabola because this is no longer a function. It won't be a function. You cannot pass the vertical line. Here's when we graph these square root, when we graph them, just keep in mind, we're graphing what's called the principal square root. I want to know if it's the positive value only. I want to know what is the square root of 1? 1. I don't want the solution to it, which is 1 and negative 1. So when I plug in 4, what you'll get for y is 2. Okay, so something like that. All right, so principal square root, that's what it's called. Okay, you're just gonna see something like that. I just want you guys to have a heads up on that. All right, that's it for that one. And then one last thing I want to show you guys is a throwback to probably Algebra 2. I don't think many of you learned it in Algebra 1, but it's probably a throwback to Algebra 2. I'm going to give you a quadratic, but I'm going to write it like this. I'm going to say x squared minus 8x equals 3. And I'm going to ask you to solve this, but I'm going to ask you to solve using complete the square. Okay? Complete the square. Otherwise, shortcut is C. Now, you guys know this is a quadratic. Now, it's not in standard form right now because this 3 is over here. So it's A, B, and, well, the C is over there. It'd have to move here and be a negative 3. Now, you guys have probably done quadratic formula, X method factoring, yada, yada, yada. I'm telling you right now, this isn't factorable. You could use quadratic formula, and that's perfectly great. But just letting you know, we're going to show you a complete and square problem on this next time. So I'm going to show you how complete the square is done. It's kind of a review. Just remember one thing. Just remember that formula. All right, let's go step by step. This is the way I like to do complete the square. Some people have a slightly different way. It's all the same thing essentially. Okay. So for complete the square, here's what I'm going to do. First, I'm going to add. Let me just make sure. Okay. So first thing with complete the square is let's just say it was given to us like this. Let's say it was given to us like this in standard form. Great. First thing we do is we move that c over. X squared minus 8x equals 3. Now I put a little bit of space here, and you'll see why. Okay. Then I'm going to add b over 2 squared to both sides. Okay. So let's do b over 2 squared. The b over 2 is going to be, the b is negative 8 over 2, which is going to be negative 4. And I'm going to square that. Negative 4 squared, negative 4 times negative 4 is 16. So I'm going to add 16 to both sides. That's going to get me x squared minus 8x plus 16 equals 19. Now, the reason I do this is because this is called completing the square. What you get over here all the time is a perfect square. What do I mean by perfect square? There's one number that multiplies by itself to get 16, but also adds up with itself to get negative 8. It's the same number. You want me to do X method, diamond method? I can do it. Doesn't matter. I'm just letting you know. It's going to be that same number every single time. That's why it's called completing the square. So it's really just x minus 4 times x minus 4. Because negative 4 times negative 4 gives us positive 16. Negative 4 minus 4 is negative 8. Okay? Equals to 19. But now you must figure out that if I write x minus 4 times x minus 4, another way of writing that is x minus 4 squared. It's the same thing. Is equal to 19. Well, how does that help me? Simple. I want to get rid of a square now. What can I do to get rid of a square? Square root. What I do to one side, I do to the other. Square and square root cancel. You're left with x minus 4 equals square root of 19. Now just be careful. With square root of 19, I'm going to put plus or minus square root of 19. I'm solving for this, so I want to make sure I put plus or minus for the square root. Now, we do not have a perfect square for 19. Okay? So, 1 second. Okay, we do not have a perfect square for 19, so we're just going to leave that as is. But we are going to move 4. So we're going to do plus 4 and then plus 4 here. Now, you could put the plus 4 here, but generally speaking, with problems like this, okay, they put the 4 in front, okay? So the final answer is x equals 4 plus or minus square root of 9. That is using complete square. Okay, a little bit hefty, I know, and I'm sorry I have to kind of rush through it and only do one because I'm running out of time here. I'm almost at 11 minutes. I do want to keep these short. Okay. All right, you guys. So you guys know what the routine is for the week. Oh, homework. Sorry, forgot to flip it over. Flip it over. Homework. All right. Homework questions. 6 questions here. 1, 2, 3, 4. Let's see here. Number 1 is find the sine of 105 using half angle. Then I want you to find the sine of 105 using sum and difference. Now maybe, well, sum and difference, that's from last week. Yes, it is. Okay. Implying that there's sort of a question. Okay. Then cosecant of theta equals negative 5 over 3. Well, then what would the cotangent of theta be? Be careful. I'm saying that within this restriction. Where would that be? Which quadrant? Think about that. Graph that real quick, and then solve that using complete the square. So remember, we're gonna move this 3 first, and then we're gonna, go and do everything else. And then number 6, double angle. That's about it. Thanks, guys.